Hello guys, I'm going to record this video to talk a little about the first section of probability. We're going to talk about the definition. We're going to talk about types of probability. Then we're going to talk about sample space and event. What is the sample space and event in an experiment? We will talk about intersection of two events, and we're going to talk about also union of two events. Union of two events. And we will talk about complement event as well. Then we're going to talk about mutually exclusive events. What does it mean when two events are mutually exclusive? And then the next step is going to be conditional probability, which is going to lead us to dependent and independent events. So this is a quick overview of what we're going to talk about during this video. I try to be fast and practical to make sure you're not going to spend a lot of time watching this video. Okay, so I forgot to say that we are going to also talk about additional rule. We are going to also talk about addition rule together. Addition rule of probability, which is very, very important. Okay. So let's suppose that we are rolling a die. We are rolling a die. In rolling a die, what are the possible cases? It's going to be 1, 2, 3, 4, 5, and 6. All the possible outcomes, the set of all the possible outcomes are here. The set of the list of all the possible outcomes are going to be your sample space. So what is sample space? In every experiment, the list of all possible outcomes are going to be your sample space. Okay. What about rolling two dice, for example? Let's say that your experiment is rolling two dice at the same time. The red die and the red die and the black die. Okay. So one possible case is that you can have one for red, one for black. One for red, two for black. One for red, three for black. Up until one for red and six for black. Another case can be 2 for red and 1 for black, up until 6 for red and or 2 for red and 6 for black. Okay. So if you go and list all the possible outcomes, you're gonna have a list like this: 1 1 1 2 1 3 1 4 1 5 1 6 up until 6 6. So for example, 3 and 4 refers to red die. The outcome is 3, and the black die, the outcome is 4. Okay, so this is the sample space. This is the sample space of this experiment. And what is your experiment? Rolling two dice together. Okay, or one after another. The thing is that we just look at the result of them. What is an event? So let's say that this is my question. Let's come back to the previous case, this case here. Okay, I'm gonna ask you, can you tell me what is the probability of having an even number in rolling a die once? I'm rolling a die only one time. Okay, what is the probability of having an even number? What are possible cases for an even number? It's 2, 4, and 6. So this is your event we can call it event A. Event A is all the possible cases which they give you an even number, 2, 4, and 6. Event A. We can have different events. We can have an event can be what is the probability, like the event can be event B having a 2. It's an event. What is the probability of having a 2 as the outcome? Okay. Or what is the probability of having a number less than 4? What are the possible cases less than 4? 1, 2, and 3, not 4. We will talk about less, the difference between less than and less than or equal. In fact, let's talk about it right now. Less than, it means you cannot include 4, okay? But if I tell you less than or equal, you also have to consider 4. It's a very important thing because it's gonna totally make it give you a different answer. So less than 4, it means 3 over 6. Having a 2, it means 1 over 6, okay? But what does it mean 1 over 6, 3 over 6? So we're gonna learn the very first formula for probability. Okay, this is the very first rule of probability. Probability of event A equals to number of outcomes corresponding to event A over number of outcomes in the sample space, or total all the number of all the possible cases. Okay, so for example, for having an even number, you can say all the possible cases. You have 6 outcomes and 3 of them, they are even numbers. It's going to be 3 over 6. This is the very basic formula of probability. Remember, the condition for using this formula is that the outcomes of an experiment are equally likely. What does it mean? The probability of having 1 or 2 or 3 or 4 or 5 or 6, they are equal to each other. They are all 1 over 6. 1 over 6. 1 over 6. In this case, you can use this formula for other events as well. Okay? If these probabilities are not the same, you cannot use this formula. So it has to be a fair die, or it has to be a fair coin. Okay? So for example, for this die, or this one, you cannot use this formula. Why? Because the probability of one side is greater than the other one. I don't know, maybe the weight of this side is a little higher than the other side. So it's more probable to have a 4 or 5 than a 1. Okay, so these are not fair die, and we cannot apply the same formula of probability for them. As you know, probability of every event, as you know intuitively, that probability of every event is always between 0 and 1, or between 0 and 100%. Okay, if it's 1 or 100%, it's a certain event. If it's 0, it's an impossible event. 50% even chance, and to the right or bigger than 50% is going to be likely to happen. Less than 50%, it's unlikely to happen. Okay, we're going to go for an example here. Okay, so let's say that in a group of students you have 32, in a group of IB students 60, 32 take physics, 28 take philosophy, and 50 take both philosophy and physics. Okay, if I ask you what is the probability of choosing a student at random from this sample, and that student takes physics. Okay, so you have 60 students, and out of 60, 32 they have physics. Okay, so this is the probability, 32 over 60. If you want to have it in percentage, all you have to do is to multiply by 100. That number is going to be in percentage. Okay, if I tell you what is the probability that you choose a student at random and that student has physics and philosophy, you're going to tell me it's 15 over 60. Okay. As many of you know, for describing this kind of events, we prefer to use Venn diagram. Why? Because, for example, if I ask you, what is the probability of you choose a student at random and that student doesn't have both physics and philosophy, doesn't have, none of them, okay? Physics, no physics, no philosophy, okay? Well, here you don't have the number, okay? So you need to find a way to find that number, because, okay, you know what is the denominator, but what is the numerator on the top, okay? So we use Venn diagram to explain this kind of events, okay? So what is a Venn diagram? A Venn diagram consists of multiple overlapping circles, each representing a set or an event, okay? Can we go and draw the Venn diagram of the previous example here? Let's draw the Venn diagram here. So I'm going to start with the square to show the number of all of my students, 60, okay? 60 is the total number of students. I know that out of 60, 32, they have physics. 32, okay? And I know that 28, they have philosophy. 28, okay? And of course, I know that 15, they have both. 15, they have both here. 15, they have both physics and philosophy. So this is the question. Can you tell me how, if I ask you, what is the probability that you choose a student at random and that the student doesn't have either physics or philosophy? Okay, what does it mean? I'm going to find the number which is here. How many students they don't have either physics or philosophy. How can I find that number? Okay, let's find it together. I know that this value here, the whole circle is 32 because 30 students, they have physics. Out of 32, 18, or by 18, 15. I made a mistake here. Let me adjust my mistake. It's 15. 15, they have both. So 32 minus 15 is 17. And out of 20 students who they have philosophy, 28 minus 15, which is 13, they have only philosophy. So let's talk about it one more time. Let's explain one more time. 17, they have only physics. 13, they have only philosophy. Okay? 15, they have both. The total of number of students that they have physics is 32. Why? Because 17 plus 15 gives you 32. 13 plus 15 gives you 28, the total number of philosophy. Okay? If I ask you how many students they don't have either physics or philosophy, all you have to do is to say, okay, I have 16 students in total minus 17 students, they have only physics. 15, they have both. 13, they have also only philosophy. So 60 minus the total number here is going to give you 15, which is the total number of students who they don't have either physics or philosophy. So here the denominator is going to be 15. 15 students, they don't have either physics or philosophy. Now, if I ask you, what is the probability that student has only physics? Only physics. You're going to tell me only physics is going to be 17 over 30 over, pardon me, 60. 17 over 60. Okay, that's it. Now, okay, let me ask you another question. What about if I ask you, what is the probability that you choose a student at random and that student doesn't have physics at all? Okay, you're gonna say, okay, I know that 32 students out of 60, 32 students, they have physics. So 60 minus 32, 28. 28 over 60 is the probability that a student doesn't have physics. 28 out of 60. Okay. Now we have an idea of a Venn diagram, and we see that it's a very useful visual tool for us to describe different probabilities and different cases. Okay. Now let's talk a little about union, intersection, things like physics or probability, physics and physics or philosophy, physics and philosophy, not physics. Okay, so we're going to start with union. What is union? Union between event A and event B is when we say, for example, physics or philosophy. Okay, so when we use the term or in English language, we are referring to the union of two events. What does it mean, the union of two events? It means that you have to consider every part of the Venn diagram which you have A or B or both of them. So here, for example, you have only A, here you have only B, they are going to be included, and of course the part which is also in common between them. This section is giving you A or B. For example, if I tell you what is the probability that you choose a student and that student has physics or philosophy, physics or philosophy, you're going to tell me 17 plus 15 plus 13 divided by the total number, which is 60. 17 plus 15 plus 13 divided by 60, which is 45 divided by 60. So remember, it's only B, only A, and of course the part which is in common between them. This is the union. Okay. What about intersection? Intersection is different. Intersection is the common part between A and B. Okay, it's the common part. So if I tell you what is the probability in our example that a student you choose at random has physics and philosophy, you're going to tell me I have 60 students, 15 of them they have both physics and philosophy. So it's going to be 15 over 60. 15 over 60. Okay, so union, intersection. The notation of intersection is this element here, A and B, and for union it's A or B. Okay, now that we have an idea of A and or, we can talk about the very first rule of probability, addition rule. Addition rule. What is addition rule? It makes a relationship between union and the intersection of two events. What does it mean? The probability of union of two events equals to the probability of the first event plus the probability of the second event minus the probability of their intersection. This is the addition rule of probability. Okay, we use this rule many times as the basic rule to do our calculations in probability. Okay, probability of union of two events A, B equals to probability of A plus probability of B minus probability of intersection of them. Remember, I'm not telling you only A. No, I'm telling you A. And I'm not telling you only B. Okay, I'm telling you B. Whatever which is inside B, whatever which is inside A is going to be considered. Okay, so this is the additional rule of probability. I'm going to briefly tell you why we have this formula. Just quickly, I want to show you how we got this formula. So do you agree with me? This is A. This is A. Okay. And do you agree with me? This is B. Okay. Now, if I ask you, can you tell me what is A plus B? Can you find A plus B? Can you show A, probability of A, plus probability of B? You're going to tell me this is A, this is B, so probability of A plus probability of B. Do you agree with me if I add up these two cases? If I add up these two cases, I'm going to count this common part. I'm going to count this common part twice. So it's basically probability of A or B, okay, and I have to do the subtraction here, probability of A and B. So probability of A, probability of B, but I have to subtract this value here. I have to say probability of A plus probability of B minus probability of A and B to have this case. Okay. So blue plus red minus purple gives you A or B. Gives you A or B. Okay. So this is a visual demonstration of this formula. Probability of A or B equals to probability of A plus probability of B minus probability of A and B. Okay. Complement event. It's a very important formula. What is the complement event? Complement event is, for example, let's define event A is rolling an even number. Okay. Complement of A is going to be rolling a not even number, or in this case an odd number. Okay, so if this is A, this is going to be your B. Whatever which is not inside of A. Probability of A plus probability is complement event equals to 1. This is a very useful formula. Why it is very useful? Because sometimes in some questions you are asked to find probability of A, but it's much easier to go and find the probability of its complement. So instead of finding A, you're going to go and find its complement event. I think I talked about it a lot in the classroom, so I don't want to talk about it now here. Instead of, in many cases, not always, but in many cases, you're asked to find probability of A, and it's better to find probability of its complement. So you're going to say 1 minus that probability. It's much easier to solve, and it's going to take less time. Mutually exclusive events. Remember, it's not like that always between A and B we have something in common. Here we have something in common, so these are not mutually exclusive. They are not. But if two events There is nothing in common between two events. They are mutually exclusive. What you need to understand is that anytime you see the term mutually exclusive in your questions, you have to say probability of A and B equals to 0. Remember, you have to turn the words from the English language to the math language. Okay? Probability of A and B equals to 0. So think about it. Can you consider two events that are mutually exclusive? Here I have an example. Rolling an even number and rolling an odd number. These two events cannot happen at the same time. So the probability of having an even number and an odd number at the same time is 0. You cannot have it. In rolling a die once, you cannot have an even number and an odd number at the same time. It's 0. It's a recap of union, intersection, and complement. So this is union, A or B. This is A and B, and it's the complement of A. Okay. At this point, I'm going to solve one question for you, and then I'm going to go and show you some Venn diagram questions. Okay. Probability of A equals to 0.6. Probability of A or B is 0.7. And probability of A and B equals to 0.3. Find probability of B. So what is the addition rule of probability? What is the addition rule? Okay, so you know that probability of A or B equals to probability of A plus probability of B minus probability of A and B. What is given to you? A or B is given 0.7. Probability of A given 0.6. Probability of B, this is what you want to find, minus probability of A and B. This is also given to you 0.3. If you struggle to solve this, you're going to go for numerical solve, but we can also do it manually. 0.6 plus minus 0.3 is 0.3. To the other side, it's going to be minus. So probability of B is 0.7 minus 0.3, which is going to be 0.4. 0.4. Okay, so probability of B is 0.4. We have two types of probability. We have theoretical probability and experimental probability. Experimental probability is based on the past data. Okay, so for example, I tell you that based on my experiment, I know that I have rolled a die maybe 100 times, and out of 100 times, I got 60, well, let's say tossing a coin. I have tossed a coin 100 times. Out of 100 times, 60 times I got a head. I got a heads, okay? So probability of having a heads is going to be 60 over 100 based on my past data, because out of 100 times I got 60 heads. Okay, this is an experimental probability. We use experimental probability almost every day in everyday language that we use. Okay, but what is theoretical probability? Theoretical probability is the probability that we are using based on the formula. Okay, so here we put the total number of sample space, and here we're going to put the favorite outcomes. Okay, for example, in the case of having heads, it's going to be always 1 over 2. Remember, these two numbers, they are not the same now. The idea is that more you do the experiment, instead of 100, if you do it 1000 times, this probability of experimental is going to get closer to the theoretical one. So for example, here is 60, but maybe in this case it's going to be 505, which is a little closer to 1 over 2. If you do it 10,000 times, or I don't know, 1 million times, you're going to have a number which is going to be a little closer, but it's still probably not exactly the same. Okay, so if you do the experimental probability many times, this value is going to get closer and closer to the theoretical probability. Look at this graph, and I think it's more than clear for everybody. Okay. Okay, now I'm going to talk about conditional probability and dependent and independent events. So what is conditional probability? I told you that probability of event A equals to the total of number of A over the total possible cases, okay, total number. So for example, if I tell you that I'm rolling two dice at the same time, what is the probability that some of them is going to be less than or equal to 3? You're going to tell me 1 1, 2 1, and 1 2 are the possible cases. So it's going to be 3 over the total number of cases, which is going to be 3 over 36. Okay, now I'm going to change my question. I'm going to say, can you tell me what is the probability of having sum less than or equal to 3, given that the second number, the second die number second, die is an even number. Okay, so I'm asking you, what is the probability of having sum of the two dice less than or equal to 3, given that the second die is an even number? So here, in this case, denominator is going to be definitely different. Okay, I'm gonna lower the value of the denominator, okay, because of any intention that I have in my mind. In this case, I'm going to consider only the cases that the second die is going to be even. What does it mean the second die is going to be even? What are the possible cases? The possible cases are this column, and also this column. So how many cases do you see here? Instead of 36, now you see 18 cases. So denominator is not anymore 36, it's 18, okay? And out of 18 cases, there is only one case which the sum is less than or equal to 3. Only one case. So now the probability is 1 over 18. What is the formula for that? What is the formula? Probability of A given B equals to probability of A and B over probability of B. Remember, B is going to go to the denominator in the equation. So this is the multiplication rule of probability. We learned about the addition rule. I'm going to write it here one more time. Probability of A or B equals to probability of A plus probability of B minus probability of A and B. Here we also have the multiplication rule of probability, which is probability of A and B equals to probability of A and B over probability of B. Or we can also rewrite it in this form. Probability of A and B equals to probability of A given B times probability of B. I can put this to the other side. Okay, we use both of these formulas a lot in our questions. Let me solve one of these exercises that I have here. Given that at least one die shows a 4, so remember, any term that you have after given is your condition. Okay, it's your B given that. Okay, so what is the probability that the sum is 7? What is the probability that sum is 7 is your A. Condition is given that at least one die shows a 4. So probability of A given B, you know that is probability of A and B divided by probability of B. What does it mean? On the top, I'm going to write probability of A and B. So it has to be sum equal to 5, equals to 7, and at least one die shows a 4, at least. So what are the cases? Let's see. So these are the total cases that at least one die shows a 4. This and this. How many cases we have? 6 plus 5, 11. So the total possible cases are 11. 11 over 36. This is the probability of having a this is the probability of having a number that at least one die shows a 4. But what about the denominator? Sum, it has to be equal to 5, and it has to be one die shows, at least one die shows a 4. Okay, in that case, so let's see, sum, it has to be 7. This is one case and this is another case, so it's going to be 2 over 36. Is there any other case? 5 and 2, no, obviously, because 5 and 2 we don't have any. 36 and 36 cancel each other out, so it's going to be 2 over 11. 2 cases out of 11 cases, they give you the answer of this question, 2 over 11. Remember one more time that your denominator is not anymore 36, it's 11. Okay, so this is the idea behind conditional probability. Okay, so what if two events are, I'm going to be faster here because honestly I'm a little tired. Okay, well, what are two independent and dependent events? So if the result of one event is not impacting the another event, that event is independent to event B. Okay, so when the outcome of event A does not affect the outcome of event B, that is an example of independent event. Remember, independence is directional. Maybe one event is dependent upon the other one, but the vice versa or the inverse process is not valid. Okay, so this is something to consider. For example, in rolling a die and tossing a coin, the outcomes of each one ideally is not going to impact the other one. So these two events are independent events. So what does it mean when you see the term independent event? Anytime two events are independent, you can say probability of A and B, probability of A and B equals to probability of A times B. Probability of A and B equals to probability of A and B equals to probability of A times probability of B, or probability of A equals to probability of A given B, or probability of A given B not. Basically both of them are correct. Okay, and you can use both of them in different questions to solve your questions. So remember, anytime you see the term independent, it means probability of A and B equals to probability of A times probability of B, probability of B, or probability of A equals to probability of A given B equals to probability of A given B not. What does this term, this equation mean? What does it mean? It means that no matter what happens to B, probability of A is always going to be the same. No matter what happens to B, even if you condition me by event B, the final answer of a probability of A is going to be always the same. Okay. Okay, I think for now it's enough. We should talk about tree diagram as well, which I'm going to leave it for later. Okay, let me see. So let me just have a quick recap of all these formulas that I've told you. So a quick recap, we know that probability of every event equals to the number of that event over the total number. We also know that probability of every event is always between 0 and 1. We know that probability of every event equals to 1 minus probability of its complement, which is sometimes very, very helpful. We know the addition rule, which is probability of A or B equals to probability of A plus probability of B minus probability of A and B. We know also the multiplication rule, which is probability of A and B equals to probability of A times probability of B given A. Or you can also write probability of B times probability of A given B. Let me see. Yes, that's correct. Okay. Both of them. So this is the addition rule and this is the multiplication rule. Okay. We also know that in the given probability of A given B equals to probability of A and B over probability of B. Okay, that's, I think, a quick recap of whatever we talked about. Now, if two events are mutually exclusive, it means probability of A and B equals to 0. And if two events are independent, it means probability of A and B equals to probability of A times probability of B. I'm going to later upload another question that I'm going to solve for Venn diagram. Thank you. Watch that video as well, please. Watch it. Thank you.